This video is on graphs of radical functions, so square roots, cube roots, that kind of stuff, everything we've been talking about. Here's what it looks like. So the basic square root of a function, of a variable x, looks like this. It starts at 0, 0, and it makes this curve going along these numbers that have perfect squares. Now notice the domain is everything bigger than 0 because there isn't a square root of -1. Not a real one anyways. And when you look at the cube root, it looks like this. This time its domain is all real numbers because you can actually have a cube root of a negative number. Since -3 times -3 times -3 equals a negative number, it's possible with the cube root. In fact, for all even root functions, it's going to look similar to this. Like fourth root has a little bit more of a curve, and 6 a little bit higher, and that kind of stuff. As far as odd roots are concerned, they're all going to look like this. Again, some of them will have a skinnier piece like that. Some of them will be bigger like that, just depending on what that number is. So what we're mostly talking about is these transformations. This is all review. We've talked about it before. The only difference is your parent functions are going to be radical functions. So square root of x, or cubed root of x, fourth root of x, right? Fifth root, 10th root. It holds true for all of these. So we've got vertical shifts up, down, left, right. Then we've got a reflection over x. There's also a reflection over y. And then this vertical idea of stretch or shrink. You've seen all these before. We did them in the exponential and log graphs chapter. The main idea is looking at where is the change happening. So f of x equals square root of x is our beginning one here, and you'll notice this +4 is what's different between this guy and that guy. So we added 4 on the outside. Now what do I mean by outside? Well, with every radical, there's something inside, and that's underneath the radical, and then everything else is outside. Okay, so for vertical shift up, adding outside. So you'll notice this 4 is not underneath the radical. Vertical shift down, you're subtracting outside now, which is this -2 right here. Doesn't matter that it's the cubed root. It's -2 and it's outside the radical, so it would be a vertical shift down. Then there's horizontal shift left, which is adding inside. So if you'll notice here inside the radical, the change is that we've put a +1. It's not a +1 out here. It's a +1 on the inside, which makes it a horizontal shift left. Now notice that seems a little awkward. We're adding a number and it's moving left. That feels a little backwards. Notice down here when it's got x -5, that's inside. We're subtracting a number, but we're actually moving to the right. To me it feels weird because on a number line, if you add something, you're moving farther in the positive direction. If you subtract something, you're moving in the left side. So the thing to remember about this is that inside is always backwards. If it's +1 on the inside, it's actually left. If it's subtract 5, it's actually to the right. Next one is reflection. So you can just think about this as a negative out in front. You don't have to worry about the whole thing and just part of it. This one would be a negative on the x. See how here the negative is outside, here the negative is inside. Okay, vertical stretching and shrinks, it's easy to recognize those because you're multiplying. The rest of them you're adding, subtracting, or just throwing a negative there. And again, it's outside, which means out in front here. And if you multiply by a number bigger than 1, so let's say your number was A, then A greater than 1 is a stretch. And it's a shrink if it's a fraction between 0 and 1. So this right here, 5 is greater than 1, so that would be a stretch. This number right here, 2/3, that's less than 1, greater than 0, that would be a shrink. And those are all the different transformations we can make. Now, I gave you a little cheat sheet. Looks like this. This is just an easy way. Make sure you cross these off. We're taking those out. This is an easy way to determine these changes, these transformations, just by following what's happening here. So, looking at an example, right here, f of x equals the square root of negative x. So, first question you have to ask is, did that change? So this right here, this negative is the change. Normally it's just square root of x. Negative inside. Now it's underneath the radical, so that means it's inside. What just happened? All right, looking at your cheat sheet, we just said it was inside and it was a negative. That means that my transformation is a reflection over the y-axis. Okay, next one. So this one has a fourth root, which means the original one just looked like that. So we'd look at it and say, okay, there's the change. We added 5. And then you go, where did it happen? Well, it's underneath the radical, which means it's inside. Okay, looking back at our chart, inside. So we're still here, still in this line. And we added. So our transformation was that it went left 5. Let's try this next one. This one has 2 changes. It started out as the cubed root of x, and we've got 2 changes. We've got this right here, and we've got this right here. 2 changes. So let's talk about this one right here. What we've done is we've subtracted 1, and then you got to ask yourself where. Well, it's underneath the radical, which means inside. Okay, subtracting 1 inside. Let's go back to our cheat sheet. Let's get some of this other mess off of here. So again, we're inside, so we're on this line right here, and we're subtracting, which means our change was that we moved right. So this guy was that we moved right 1. Okay, another one. This guy right here, this 2. Now it's not 2 plus, it's not minus 2 or 2 minus or anything. It is just a 2 out in front of there. And there's no symbol, which means it's automatically multiplication. So we are multiplying by 2. Then you have to ask yourself, where? Well, here's the radical. This is inside the radical. This is outside the radical. Okay, cheat sheet says outside. So we're in this line right here. And we added, just kidding, we multiplied, which means we are either a stretch or a shrink. Now the second thing you need to look at for stretching and shrinking is that number that's out in front. So we've got a 2, and since A is greater than 1, that's 2, we would say it's this type, which makes a stretch. So we would say a vertical, just V is fine, stretch by 2. This v right here, for what we're doing, it would be okay if you left it off because we're only focusing on vertical transformations, or sorry, vertical stretches and shrinks. But know that normally you would have to tell it vertical or horizontal because you can actually make a stretch and a shrink either way. Okay. Next one. This is a fifth root. So your original one looked like this. Fifth root of x. 2 changes. We've got this guy out here and this guy out here. Okay, let's start over here. Looks like we've added 1 and it happened outside. Outside because that square root line is not over top of it. The radical is not, the +1 is not inside the radical. Sorry about that. So we added 1 outside. Cheat sheet says, okay, when we go outside and we add, okay, outside add, that means our change is that we went up and then you tell it the number by, up 1. Circle this guy back here. All right, let's talk about the other change. This is a negative. And is it outside or inside? Well, it's not underneath the radical, so it's got to be outside. All right, back to our cheat sheet. We're outside. We've got a negative, which means it's a reflection over the x-axis. Reflection over the x-axis. Okay, looking at these ones, here's our original. Here's our new one. There are 2 changes. This one right here and this one right here. So this one we are adding 4 and it's not underneath the radical, which means it would be outside. Cheat sheet, then you would look at your cheat sheet and you would say that that means that we are moving it up 4. This other change, now we are subtracting 3 inside. It's underneath the radical, it's inside, which means we are going, so you can't remember that one, so we got to go our cheat sheet, inside, subtract, means we actually went right. So we would say right 3. Okay, next one. Original is cubed root of x. Inside, oh, this is a bad example. Pretend that 8 is out here. We didn't do the horizontal one, so that's okay. So inside here, there's a negative inside. And then outside, there's this 8. We're multiplying by it. Okay, you look back at your cheat sheet. The green one says we've done a vertical stretch by 8. And the red one is negative inside, which means a reflection. This time it's over the y-axis. Okay, these next ones, it's backwards now. Now I'm asking you to actually write a function for them.